welcome to the next session on operations research. In this session, we will take up the third numerical on the topic of dynamic programming. We will solve the type 3 problem, that is on stagecoach or shortest path problem. A salesman is planning a business tour from Mumbai to Kolkata, in the course of which he proposes to cover one city from each of the company's different marketing zones en route. As he has limited time at his disposal, he has to complete his tour in the shortest possible time. The network in figure below shows the number of days time involved for covering any of the various intermediate cities. Time includes travel as well as working time. Determine the optimum tour plan. So as you can see over here, there is a tour from Mumbai to Kolkata. We are starting from A and we will go up to O. There are various cities in between which the salesperson has to travel through. So I'll write down the solution first. So I'll write down starting from A, the cities of various marketing zones may be considered as distinct stages. So I'll write down stage 1. A will go to either B or C. So B or C is stage 1. Stage 2 is, it will go to D, E, F or G. Anyone. Then stage 3 is going to H, I, J, K. Any one of them. Stage 4 is going to either L, M or N. And stage 5 is best route to the destination O. Now we'll start with stage 1. At this stage we don't know whether B or C, which lies on the overall shortest route. But if the shortest route is from A to B, which is nothing but AB, this value over here given is 10. Then suppose if it is A to C, this will be 11. And these are the only routes that are possible, because A is going either to B or to C. Now I'll go to stage 2. A, B, and then he can go to D. So I will add 10 plus 8, that is 18. Or he may go from A, B to E, from here to here. So this is 10 plus 9, that is 19. This is one possible. Similarly, you can calculate ACE, ACF and ACG. You can see over here. So ACE, A to C is 11, C to E is 7. This is 18. A to C is 11, C to F is 8. So this is 19. A to C is 11 and C to G is 9. So this becomes 20. Now I'll write down from the above. You can see that these two are for E. Shortest routes are A to D is 18. A to E is also 18. A to F is 19 and A to G is 20. Then I'll go to stage 3. So now we will look at this zone H, I, J and K. So we will start with A, D, H. A to D is 18, D to H is 5. So this becomes 23. I can also calculate AEH. A to E was 18, E to H is 6. So this becomes 24. I have completed for H. Next I'll go to I. I can go from ADI. I can go to AEI. I can go to AFI. Now we will not halt at B and C. We will go to ADI, AEI, ACI. AG to I is not there. So let me add all of these. A to D is 18, A to E is 18, A to F was 19, D to I is 6. So this becomes 24. E to I is 5. So this is 23. And F to I is 7. So this is 26. This is all for I. Next I'll calculate for J. For going to J, you can go from AEJ. You can go from AF to J and AGJ. A to E is 18. A to F is 19. And A to G is 20. This I have already written. Now E to J, you can see over here it is 6. F to J is 5. And G to J is 6. This is 24. This is also 24 and this is 26. This is for J. Last we'll write for K. To reach K there are only two ways, AFK and AGK. A to F is 19, A to G is 20, F to K is 7 and G to K is 6. So this is 26 each. This is for K. So now I'll write down from above. Shortest routes from A are A to H. Minimum is 23. A to I. Here the minimum is 23. A to J. Minimum is 24. And A to K, both values are 26. So minimum anyways is 26. So we have completed with stage 3. Now we'll go to stage 4. So we will take up these ones, L, M, N. So we will go from A, H, L. We can go from A, I to L. We can also go from A, J to L. A, K, L route is not there. So only 3 of them are there. So A to H is 23. A to I is 23. A to J is 24. H to L is 5. I to L is 6. J to L is 7. So when I add this is 28, 29 and this is 31. These 3 are for L. Next I'll write down for M. We can go from AIM. Then we can have AJM and AKM. A to I is 23, A to J is 24, A to K is 26. I to M is 6, J to M is 7, K to M is 5. This is 29, this is 31 and this is also 31. This is for M. Next, I write down for n. There are two roots. One is AJN and one is AKN. A to J 24, A to K 26. J to N is 4, K to N is 5. So this is 29 and this is 31. Sorry, this is 28 and this is 31. This is N. So I'll write down, therefore, the shortest routes from A are A to L, minimum value is 28. A to M, minimum is 29. A to N, minimum is 28. So stage 4 also completes here. Last I'll go to stage 5. So you can go from AL to O. This is O. You can go from AM to O or AN to O. AL 28, A to M 29, A to N 28. The value of L to O is 3, M to O is 4, N to O is 4. So when you add this, you will get 31, 33, 32. These all are for O. So finally I will write down, thus the shortest time from A to O is how much? 31. Now we retrace the stages backwards along the network to identify the intermediate cities along the shortest route. So you can see A to O was the final value. That is stage 5. Then we'll go back to stage 4 where we have ALO, one stage behind. Then we'll go one stage behind and we find that when you come to L, the shortest path was through H because it was the minimum value, AHL over here for L alone. This is AHLO, stage 3. When you go to AHL, A to H minimum is 23, which is through D. So this is the path to be chosen. So I will write down over here A, D, H, L, O. And in the first stage, A to D. Let's see which is the minimum value. It was only 18, which was through B. So I'll write down, this is A, B, T, H, L, O. This is the optimal route. And this is the solution. So with this, I end the session. I hope you have understood this numerical. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.